Okay, welcome back. We're gonna continue discussing optimization problems. Sorry, didn't finish the one in the last video, but it was essentially done. We already had the side lengths, and what we're gonna do is we're gonna multiply the other stuff. I just got kicked out. I've been being kicked out of places all day. Anyways, so this one is another optimization. Oh, I forgot to erase that. Optimization problem, but it is a lot more difficult than I would have anticipated. Also, I forgot to do it on the homework, so I really just need to make a video dedicated to it. Anyways, the question is, find the points on the ellipse 3x squared plus y squared equals 3. There's some hair or something. Yeah, equals 3. That are farthest away from the point 1, 0. This is kind of a weird problem because an ellipse on a graph looks like this. And so it's giving us a point like 1, 0 and saying where are the 2 points that are farthest away from this, which would be this one and this one if this was where the ellipse was placed, because the ellipse can be moved wherever you want. So to be able to understand this problem, you have to know what the parent function of a circle or ellipse is and how you can manipulate it. So lucky for us, this parent function is centered on 0, 0, which makes it easier to comprehend and think about. So we need a second equation to be able to solve for our derivative. We need to have something that we can plug in as a system. So this equation is the toughest jump, but once you figure it out, it works. It's going to be derived from the Pythagorean theorem, which is x squared plus y squared equals d squared. I'm using d just for distance. And the weird part here that will confuse you is that we're pretending that this is 0 and 0, or it's starting from 0 and 0. But in reality, we're going to be putting 1 in, so it's going to have to end up like x minus 1 squared plus y squared equals d squared. Now, why is this? Because on a triangle, you're going to be computing the Pythagorean theorem with a, b, and c. And we're pretending that this is 0, 0. However, the point that we are starting at is 1, 0. So what you have to do is you have to subtract 1 from a, or just add 1 to it, so a plus 1. And then you'll get what you need. Or you can be like a minus 1 to get you to 0. I'm not really sure which one it is, theoretically, but I do know that the correct one is minus 1. Or just minus the coordinate that you're using. Now, if it was, hypothetical here, if it was like 3, 5, we would adjust accordingly. It would be x minus 3 squared plus y minus 5 squared equals d squared. It's the Pythagorean theorem, but we're adjusting for where our origin is, because it's a transformation. But we don't have to worry about that right now, or any more about it. Just keep in mind that that's what you're supposed to do to transform your graph. So now we have our second equation, and all we have to do is solve our derivative, or solve it like a normal optimization problem, going through the finding of the derivative and the other stuff. And we're looking for a maximum, so just keep that in mind for later. So using the first one, y squared equals 3 minus 3x squared. Might as well change colors because I'm solving it now. Okay, now what do we have to do? We have to plug it into the original, or to this one, and luckily we don't have to do any squaring right there. It's just y squared equals 3 minus 3x squared. So x minus 1 squared plus 3 minus 3x squared equals d squared. Now we take the derivative, just use a chain rule, 2x minus 1 plus, well, it's going to be minus 6x. Easy. Now it's 2x minus 2 minus 6x is going to be negative 4x minus 2, which is going to give us x equals negative 1/2. That's as simple as that. So now that we have our x, we can go back and plug it into the equation. So head back to the original, and we're going to have 3 negative 1/2 squared plus y squared equals 3. And just solve for that. So 3 times negative 1/2 squared. So negative 1/2 squared is going to be 1/4, which is going to end up with 3/4. 3 times 1/4 plus y squared equals 3. So 3 minus 3/4 equals y squared. So y squared equals 2.25, which is just 3 minus 0.75. And all we have to do is take the square root of that, which is conveniently 1.5, 3 over 2. But since it's a square root, it's going to be plus or minus 1.5 or 3 over 2. So y equals plus or minus 3 over 2. As such, we're going to have two coordinates as our final answer. We're going to have 3 over 2 and negative 3 over 2 for our y values, and negative 1/2 for both of our x values, because we only have one of those. Now, you can take it a step farther and confirm that these are actually the maximum distances by taking the second derivative of this, this bad boy, and change color again. Love color coding. So is equal to, it's just going to be negative 4. So remember back from the maximum and minimums part, when your second derivative is negative, that means you are plateauing. Negative, negative, sad, sad, or just sad face. Which means that you're going to have a maximum at that point. Now, if it had been positive, we would have been like, oh my gosh, that's the closest possible distance we have. But since it's second derivative is negative, we know that it is a maximum right there, and that it is the farthest possible. These are the farthest possible values of x, a way that we can have, which correspond to the values of y. Anyways, that's how to solve this. I hope that was helpful. Essentially, all you have to do is just plug it into the Pythagorean theorem when you're looking for distance, and you better know your parent functions, or else you're screwed. Anyways, that's all for this video. I'll see you in the next one.